Hello and welcome. My name is Darren Guinness, and I will be presenting our paper, Caption Crawler, Enabling Reusable Alternative Text Descriptions Using Reverse Image Search. This work was done during a summer internship with the help of my co-authors Ed Cutrell and Mary Morris. So images are used online to convey a wide variety of information and can be critical to understanding the contents of a web page. However, understanding images can be a difficult task for individuals with vision impairments. Image descriptions such as alt text, image captions, or ARIA labels can help, but are inconsistently adopted and often abused. Abuses such as describing the image as image or using file name as alt text results from the fact that the presence of alt text is weighed when ranking pages on search engines or when using accessibility checking tools, while the quality of image descriptions is often not taken into consideration. As an example of an inconsistent user experience, on Site 1, we are presented with an image of a mountain covered in snow. However, there is no alt text present which describes this image, which means that a screen reader user either skips this image or is left to guess its contents based on the text in the rest of the page. While on Site 2, we see an image presented. However, this time the user is provided with a better description: Antarctic volcano Mount Erebus as seen over the NASA's Peace 3 right wing during the approach to McMurdo Station on Ice Airfield. Wouldn't it be great if we could have gotten this caption on Site 1? There are a few different methods for generating image descriptions: crowdsourcing, machine-generated approaches, and hybrid approaches, which use a mix of automation and crowd. Crowdsourcing has been used to make images accessible to people with vision impairments online. In the ESP game, sighted players compete with each other by providing captions for images online. In VizWiz, image descriptions were shown to be created by crowd workers in near real time. While in friend sourcing, the users were able to leverage their social network in order to get image captioning. In interaction proxies, end users were able to update inaccessible artifacts for subsequent users while browsing directly using a proxy. Captions can also be generated using vision-to-language systems. Systems such as Microsoft's Caption bot or Facebook's automatic alt text use trained models to produce a caption automatically. These systems produce image descriptions at little to no cost to the user, but can be inaccurate or miss important contextual information. Another approach for generating image descriptions is to use hybrid systems, which use a mix of automation and human editing or verification. In Marie 4, users were able to search for captions for an individual image using a custom search engine. While in Web Insight, users were able to receive captions in near real time for images in the browser using an automated system and crowd workers. TweetTalk presented a system in which the user was presented with an initial automated caption, but opened up a dialogue between a sighted crowd worker and an end user, allowing the user to probe about different questions related to the contents of an image. In this work, we seek to enable human quality image descriptions without direct human costs. To achieve this, we reuse existing captioning found for an image found elsewhere on the web. While this cannot caption all images, this can improve the access to many images online. In order to facilitate this approach, we introduced the Caption Crawler, a fully automated captioning system which prioritizes human quality descriptions. This system automatically updates inaccessible images in a web page and allows users to replace poor quality alt text with other caption text. The system is broken into two parts: a browser extension and an Azure cloud service. The browser extension sends a collection of image metadata to the cloud service and updates the page with new captions as they stream in from the service. This it also allows a user to press a key in order to request additional captioning if they've found that the captioning to be of poor quality. The cloud service retrieves the collection of links to pages hosting that same image online using a reverse image search API, and launches a crawler to retrieve captions and other accessibility metadata from the pages hosting the image. When a page is loaded, it sends all of the images in the page to the server for captioning. When a caption is found, it is returned to the user via a retrieval policy. If the user wants to hear another caption, they can simply request it using a key press, and the server will produce another caption. We also upload any additional captioning found during the browser and use this for caching purposes for the next user. There are several caption retrieval methods. First, longest, random caption, bag of words, Bing caption, and caption bot. In the first retrieval method, for an image such as this, where we see an oblique angle looking upwards at a 6-story bamboo structure with foliage around it, we see the caption produces fantasy bamboo tropical house. The longest caption, which often includes additional details about the image, would produce the caption, Sharma Springs is a 6-story bamboo house constructed by the Ibuku in Bali. While the random caption would produce the Laura Hardy Ibuku bamboo. The bag of words retrieval method returns a list of commonly associated words. For this image, it would produce, image may contain Bali, bamboo, houses, Ibuku, and Sharma. Bing's reverse image search can occasionally produce a caption for an image. In this method, Bing uses a natural language processing model to summarize the text surrounding the page to produce a caption. For this image, the caption would read, in this bamboo tree house in Bali, they've implemented a bamboo bridge to enter the dwelling. Caption bot uses a trained computer vision approach to produce a caption automatically. For this image, it would say, I can't really describe the picture, indicating that the system has failed in retrieving a caption. When the system starts crawling for an image, it first gets a list of URLs to pages hosting that same image using the reverse image search API. The system then launches a multi-threaded crawler for each image request over the collection of results. This crawler then scrapes accessibility metadata from pages hosting the image, which is then sent to the database to cache the information for subsequent users. As captions are found, they are sent to the browser according to the selected retrieval method. In order to assess the system performance in the worst case scenarios, we performed an automated crawl of Alexa's top 500 most popular websites. This crawl was performed over 10 categories of the Alexa top 500, sampling the top 25 and bottom 25 pages from each category. The database lookup was disabled to force the crawler to go through an exhaustive crawl for all images on the page in order to gauge worst case performance. The captioning found during this automated crawl served as an initial cache for the user study. The automated crawl went over 481 pages, finding over 8,000 images without alt text, and was able to caption about 12% of them, or 1,000 images, during the browsing session. The average caption latency was about 18 seconds. This showed that even in the worst case performance, the system is still able to produce human quality captioning for many images in the short browsing session. To assess the system's performance in more of a real-world situation, we performed an in-situ evaluation with regular screen reader users. This assessed system performance on the long-tail pages rather than the most popular globally. The study was gender balanced, and the participants were free to visit any page they would like with the system on. They were encouraged to give feedback about any aspects of the system and assess performance using Likert scale questions at the end of each page. There was a total of 72 pages visited, 67 of these were unique, and 13 of these pages overlapped with the Alexa crawl. When examining the results of the user study, we saw a significant reduction in uncaptioned images. We also found that participants enjoyed receiving human quality captioning, although the quality was inconsistent, varying in language, level of detail, and even political orientation. However, we observed participants using multiple captions in order to build a larger understanding of an image and build on its contents. Although we have seen alt text coverage improve from about 50% to about 72% in the past decade, alt text abuse is still present and affected our results. Captions were inconsistent, including level of detail, language, political perspective, and more. But this could be a stepping point for customizable image descriptions, allowing a user to select their preferred language, image details such as presence of color or spatial-related captioning, and political orientation in order to enable a more focused image description. We also saw that captions occasionally contained credits, caption credits, which provided additional confidence to user about where they were coming from and who had produced them. These were often associated with accurate caption text and often meant that they were from a reputable source. We found that there was a few limitations that we observed during the user study. Mainly that we had high latency, which had resulted from a depth-first search due to memory constraints. We also saw occasional failures in the system to retrieve captioning when there was one present. This had happened because encrypted images were used, allowing us to not be able to request the image to be captioned from the reverse image search. So what this really means is that we can provide human quality captions without direct human costs. And we also found that users appreciated multiple descriptions of an image and used them to build a mental model of its contents with multiple. We also saw that although alt text coverage has improved over the past decade, alt text abuse is still very much present. So what this means for search engines is that while presence of alt text is currently being used to weigh search indexes and improve page ranking, we have seen that this has also forced users to, or encouraged users to put poor quality alt text in just to basically satisfy accessibility checkers and search engine optimization. So we believe that the search engines should randomly sample alt text using a human rater for quality, and reverse image search should also include accessibility metadata returned in the results to enable this system to be run entirely using only the browser extension. Thank you for listening, and if you have any questions, let me know.
Hi, Kelly Mack, University of Illinois. Thank you for this talk. It's a beautiful project. So I was just curious, have you considered adding to the system by pulling possible captions for pictures that already have alt text, just because I've been doing a lot of work in this, and a lot of times the alt text that does exist in these images is so poor quality, or is that just too much latency to be considered?
Yeah, so we actually are pulling alt text from basically existing images found anywhere on the web. But the latency does vary. Does that answer your question?
So does the system actually pull alt text even if for images on the page that do have alt text, just in case it's poor quality alt text? Or would that increase the latency too much?
Yes, so users can actually replace any sort of alt text in the page with captions that our server has found. We actually also upload any alt text that we find during the browser session, just to make sure that we can basically cache as much results as possible.
Awesome. Thank you so much.
Hi, this is Lauren Burke. I'm a third-year PhD student, and I really appreciate your presentation, especially the focus for accessibility. I also wanted to look at low vision individuals and using alt text, and wanted to know if there's direct feedback. I know that they're not able to really view the picture because of their low vision, but I also wanted to see if there was more we could bring in as far as context, and also if there's any feedback that is offered to you saying that this is not really on the mark or it's way off the mark, and wanted to know if you had done any research around that area as well.
Yes, actually a part of the project that is not necessarily mentioned on this presentation was actually a survey using sighted and blind participants, which we kind of gauged quality and preference in terms of which types of captions should be retrieved. So we are looking into allowing users the ability to provide feedback to us, but we have not incorporated that. But we have kind of studied how best to produce and retrieve captions from these user bases.
Hi, Annie Ross, the University of Washington. I was wondering, you mentioned that sort of the quality might be correlated with where it was captioned, whether it was sort of more sites that were more trusted.
Mm-hmm.
Perhaps have you considered using that as a filter to perhaps help with latency or to get the best captions to either to sort of have a more curated set of sites you're looking at captions from?
That is a great idea. We have not done that thus far, but that seems like a great next step.
Great, thank you.